Tried and Blue, a play on the phrase tried and true, the Erland Tried and Blue blog and podcast covers past and current successes that prove how effective and reliable our construction management services are. Welcome to the Tried and Blue podcast. I'm your host, Nicole Harrison. Today I'll be talking with members of our Advanced Technology and Life Sciences team, Jay Sturdivant, Matt Combs, and Greg Conboy. We'll be going over CoLab Solutions, which is our new collaborative lab and cGMP-focused service geared towards life science clients, as well as what makes Erland a great partner on these types of projects. But before we get started, Jay, Matt, and Greg, can you tell the listeners a little bit about yourself?
All right, my name is Jay Sturdivant. I am a project executive in the Advanced Technology Life Science Group. My role is that I manage multiple projects, multiple project teams within the group for both schedule and financial requirements to meet or exceed the client's expectations.
My name is Matt Combs. I am a project manager at Erland Construction. Basically, when Jay and Greg have gotten the pre-con well underway, I'll start to get involved and actually work with you to turn your project into a reality.
I'm Greg Conboy, the lab development manager within Erland Construction's Advanced Tech Life Science Group, and I've been with Erland for 35 years. And one of my roles is to, in a sense, pull all the information together from the owners, from the user groups, the lab managers, and it's to assemble a package that then gets turned over to the design team. And that package is what we call the basis of design.
Awesome. Thanks for letting us get to know you all a little bit better. Now let's take that a step further. Matt, when you were a kid, what did you want to be when you grew up?
So I wanted to be an airline pilot. And my father, who worked at Tilcon in Connecticut, used to do work at Bradley International Airport. And I remember being a kid and seeing all the construction of the runways and stuff out there. So I guess I didn't end up too far away. I just didn't make it off the ground.
And we're happy about that. And how about you, Jay? What did you want to be when you grew up?
I wanted to be an architect or an engineer, and I grew up across the street from a small construction company, and I was always impressed with their equipment. And they were an excavation company, and then down the street was a residential builder, and I kind of got caught up with drafting and designing houses with him. And so my interest has always kind of been in the building construction field.
Awesome. And last but certainly not least, what did you want to be when you grew up, Greg?
I want to be involved with federal law enforcement, and that's what my educational background is. And after graduating from college, I pursued that career and realized that it's not something I wanted to do. And so I fell back on construction and finished carpentry, which I had grown up around.
So all of you had a little bit of experience in construction in one way or another while you were growing up. And now we're all here. All right, let's jump into hearing more about CoLab Solutions in Erland's Advanced Technology and Life Sciences Group. I'm now going to hand over the mic to Greg to moderate the discussion.
Thank you. One of the first questions we get asked is, what was our thought process behind creating CoLab Solutions? And when you look at how the industry has evolved over the past 10 years, there is no standard project. There is no one way of putting it together. In some cases, the owners are bringing design groups on board. They may be bringing an owner project manager on board. But really, one of our thought processes and what we feel is one of the best solutions is get the construction manager on board right up front. And they can help facilitate the process and, again, pull all the information together. And this leads to a quicker time to market. So that is part of the reasoning behind the development of CoLab Solutions. So with that, Matt, did you want to talk about what service you feel this brings the client, or what added service this brings the clients?
So I think certainly in the market right now, the life science projects are very hot. People are competing for space. The technology is evolving very quickly. People are trying to get into their market sector as quick as they can. And you're talking about something where work is highly technical. The infrastructure for the space that you need has to be finely tuned to what you're going to be putting together as your product. So you want to get it right, and you have to have some speed to market in order to be successful. I mean, at the end of the day, everybody's a business. So I think that the planning and thought pays dividends in the end. It helps to make sure that the product is what they need and is delivered in a timely manner without having to do rework as soon as you move in.
Jay, do you have comments on what value you think it brings the clients?
Well, the value it brings to the client is the earlier we get involved in it, the earlier we can understand their needs, what their function is, what they are producing in the lab or what they are producing in the plant. It enables us to better be in tune with the actual process, understanding it start to finish, what space requirements, what water requirements, what air, negative air, those types of requirements. The sooner we're on board with it and we understand their process, the easier it is to accommodate the building to their needs and to work with the architects and engineers to meet their needs.
Great, thank you. One of the other questions we get asked all the time is what makes life science construction different from commercial construction? From my standpoint, it's not just building floor, 4 walls, ceiling, and a floor. You're taking it to the next level. The mechanical systems that go into these type of buildings are infinitely more complicated. You also have a number of code issues that come into play depending on what type of a facility it is, whether it's semiconductor, biotech, pharmaceutical, medical device. So you really have to know what the codes are and understand them and see what implications they have on the construction. And then one of the other major differentiators is always the process utilities, whether it's the process piping, how it's run, the cleanliness of it, and also it's all about the testing that we have to do once we get one of these facilities constructed. Matt?
So I think I totally agree with all the technical aspects of it. But I think to me, you're building your tool. You have to think of your project as it's a tool. It's almost like a piece of equipment that you would put inside of the building later on, right? You're trying to build yourself a tool that is going to allow you to be able to create whatever your end product is, whatever the thing is that you're trying to. So it's a big investment, and it's something that you want to be right, and that it needs to be quality, and it needs to be precise, and it needs to work the way it's supposed to work. Where if it was just an office space or another commercial building, that's more of a means to an end. This is, I like to think of it as just the building itself is the first tool. It's the first piece of equipment that moves into the building.
Jay, your thoughts?
So one of the major differences between commercial and lab and life science construction is the fact that it's really a building, and the mechanical portions are like a building on steroids. We're looking for triple the MEP requirements. Typically, we're at least double on the structural requirements for the space. So it takes a little thought, and it takes a lot of coordination on what equipment's going where, so that the structural requirements are there. The coordination for the MEPs, so the labs are getting fed properly as opposed to the office spaces and collaborative spaces. So there's a lot more coordination that would go into a lab space as opposed to an office space.
What do you mean? It's on the paper. It fits. It has to. Somebody drew it. It has to fit.
Absolutely.
Matt, what do you think are some of the hot buttons for the life science clients right now?
I mean, to state the obvious, it's highly competitive. There's a lot of stuff going on. People are fighting for space more than anything else. People are fighting for the resources, whether it be, in Boston, the universities and people coming out of school, the space to be right around that. Certainly it kind of lends into why a lot of people are starting to look at retrofitting other spaces, former office spaces, seeing if those can be converted or any other space that they can find. Just the price of real estate obviously is going up. And certainly right now, the cost of construction materials are going up. I mean, even simple commodities are very volatile. So I think that's a big challenge that's in front of them. But certainly to the other side, like we've talked about, the speed to market. Nobody wants to miss out on the opportunities that are in front of them right now. So you need to be able to find the right space, move decisively, and get open as quickly as possible.
Jay, your thoughts?
What we're seeing for hot button issues, and we're seeing a lot of it, is the millennials of the future certainly don't want to work in the old style lab that has one window at the end of a long corridor. Today, people want to be able to work in an open, more collaborative lab space, lots of glass. They want that space to be modular. They want to be able to move as different assignments when the lab come up. They want to be able to formulate the lab a modular venue so that they can set up teams within the lab that are working together. And then really lots of glass, lots of collaborative space, lots of huddle areas. And essentially, Matt hit it right on the head. A lot of it has to do with speed to market. We're getting a lot of calls on repurposing of existing buildings, and some will work very nicely for repurposing into labs, but in most cases, you get an awful lot of buildings that won't meet the requirement based on floor-to-floor heights and things like that.
So in a sense, what you just talked about, not only is it the hot buttons for the clients, but it's also some of the trends within the industries. So it's not just working within a four-walled envelope. You have to have the amenity spaces or the amenities to go along with it to attract the to attract the researchers and lab operators to give them that environment that they want to work in, not that they have to work in.
Yeah, I mean, one of the projects I'm working on right now, in their facilities on campus, they have, nap pods, and they have certainly a big cafeteria, and they have these impact points that the interior designer calls catalyst points. And it's basically different people from different parts of the buildings might cross each other, bump into each other, create an opportunity for a moment where, hey, haven't seen you in a while, you can pull off to the side and have a conversation. So they've created like a lot of nooks and banquettes and, game areas and things like that where you can kind of have those interactions with other people. So definitely a different work style.
Yeah. So Matt, what do you see in the life science clients that they need to consider when they're looking to hire a construction manager? What are the key points that they should be discussing or trying to get more information on?
So, I mean, your construction manager, especially for something like this, I mean, experience is certainly obviously important, but somebody who's going to be part of the team early on. You don't want a commodity. Yeah, it's not one of those things where you can say anybody can build this. I'll figure out who my builder is going to be later on. Understanding the concept and having somebody who can work with your design team early on is going to save you a lot of headaches later on down the road of things that didn't work out. An experienced construction manager is going to, have lived through some of the pains already and is going to help you steer away from them. It also builds a lot of dedication. I've been on projects for, that are 2+ years long, and they feel like, sometimes they feel like they're going to drag on forever and you have sleepless nights over them. But I'll tell you, there's no better feeling than that dedication that you have to the team. And all around between the client, the design team, us as the builder, the subs, everybody. It builds that camaraderie. And that's what really, to me, makes for a successful project. When we're all playing into each other's strengths. And we're all at the table early enough where we can help decide what the destiny of the project is going to be.
Jay, did you want to comment on things like coordination or pre-purchase?
Oh, sure. So again, as Matt said, the experience in life science is huge. It gets you the team that knows that market. They understand what products within that market need to be pre-purchased in advance to meet or exceed the owner's schedule, and also to fall within the budget parameters of the job. It's simple things like just BIM and coordinating the building, and also commissioning the building. But having an experienced team also reduces your risk, and you end up in a risk-averse situation. You also end up in a guaranteed outcome. An experienced team will help you get the guaranteed outcome.
One of the things that I see, especially with some of the newer startup companies, they may be developing a new technology or a new product. So they know their technology, they know their product. They don't know construction at all. So they need to bring in somebody that's going to guide them through the different steps. And that's where I think we can provide a real service.
Yeah, you definitely want a trusted advisor. I mean, you need somebody who's going to, everybody knows something a little bit different and bring something different to the table. Like Jay said, I mean, understanding and identifying the risks, and being able to meet with a client and figuring out, it's actually kind of energizing when people tell us their story about the things that they're working on building and trying to bring to the market. I mean, it's just, there's some wild stuff that's out there. And I mean, that helps to kind of build the vision of the project, and help understanding what your outcome is helps us help you to meet what you need. It's a tremendously exciting industry to be in right now.
Yeah, we're seeing more and more artificial intelligence applications into these labs. We're seeing a lot of more robotics and automated procedures, and those all have to be incorporated into the labs. And in some cases, we have robotics not only in the lab, but they pass outside of the envelope of the lab. So we have to coordinate all of that work through different airlocks and stuff like that. So there's a little more to it than just building a building. We've got an awful lot of unexperienced companies trying to break into the market. And so for owners, it's really critical that they understand the team's experience and the company's experience in that market.
Great, thank you. So one of the things that we get asked all the time from developers that are sitting with empty buildings is, how can I turn this building into a lab-ready building? And what are some of the challenges? Jay, thoughts?
The biggest challenge we see day one when we go to visit the building are, what was the former use of the building? A lot of times just the services to the building, the water lines, the fire department service, the electrical service outside the building, those types of things automatically can cause some issues for a user. And a lot of property owners, they'd like to convert these buildings, but then we start talking about how much infrastructure outside of the building footprint has to be done. And that has to be figured into any lease rates and that type of stuff with future clients. So it begins right there. The services in the street sized large enough to service that client. And then as we roll into the building, what a lot of folks don't understand is typically lab buildings take up to 3 times as much mechanical, electrical, and plumbing requirements. They also have probably double and sometimes triple, depending on what you're doing structurally, whether the MEPs are going on the roof or they're going on the ground. You get into some serious structural issues. And the biggest thing we see is a lot of the buildings just simply don't meet the floor-to-floor requirement. Typically, we're looking for something between, on the low side, it would be 13. On the high side, it would probably be 15. And you got to be within that range to make it work. Other than that, it gets pretty complicated pretty quickly.
So you're talking about the space above the ceilings where we
Correct.
have to fit all the mechanical systems.
Exactly.
That in
Yep.
the lab buildings, that space needs to be anywhere from 3 to, ideally 5 or 6 feet.
Correct.
Whereas most office buildings have 2 to 3 feet, if that.
Correct.
Great, thank you. What about building out of the ground? What are the advantages or disadvantages of taking a lab-ready building out of the ground?
Well, the advantage of it is you're going to be able to design exactly what you need, most likely. You're going to be able to build the building of your vision from start to finish. The downside is the length of time that's obviously going to take. It's going to be significantly longer to build something out of the ground. It has to do with what your needs are. If you're an expanding campus and you're meeting your upcoming demand for growth, then taking a building out of the ground and to meet exactly what you need probably makes sense. If you're an up and coming and you're trying to break into the market, you probably are maybe steering more towards renovating or finding an existing space to work in. I happen to be part of a building coming out of the ground right now, and I'll tell you, they had a pretty clear vision of what they needed, but just the things evolve so quickly. The technologies continue to change. We're actually making some minor changes in the labs right now because technology exists now that didn't exist 2 years ago when we started the building. As Jay mentioned, there's automation. There's a piece of automation equipment that's going to be moving into the new labs, and we're bringing some new electrical service into that. So it's a really quickly changing landscape. So I think you have to carefully consider what your needs are and what the pros and cons are. And I think that having the right construction manager and design team to help weigh those risks and the the risk rewards of those is really a tremendous asset to you being able to get ultimately what you need.
And that's also where things like flexibility and redundancy come in.
Right.
Being able to add isolation valves to process utilities so that you don't have to go in and shut an entire system down. You can just isolate a small area if a change takes place.
Yeah, a lot of labs now are looking for more flexible space within a more open concepts, mobile lab casework, quick connects to the overhead service panel so that, this setup may work for, the first year or so, but, something else might change or we want to reconfigure how we're doing things and we're setting up for new experiments, and you have the ability to be able to, within your own space, be able to readjust where things are and what you need. So I think that gives you a good flexibility.
What about redundancy? What do you see in the trends within how much redundancy some of these facilities have? And the reason why I ask that, some of the components or systems that go into these buildings are absolutely critical, and they cannot shut down.
Yeah. So Jay had hit on something else that, why is it difficult to renovate a space? Well, like you said, there's a lot of different services coming in. In a typical space, you probably only have one, maybe two types of electric power. You probably have your normal power and maybe some emergency power. In a lab building, it wouldn't be uncommon for you to have 4 different types of power, to have normal, emergency, standby, and uninterruptible power. That's a consideration that a lot of typical projects might not have. Certainly a lot more spaces want to have more uninterruptible or UPS power. When you consider that you're doing probably an ungodly dollar amount of experiments that you have sitting in refrigerators, you probably want to make sure that the refrigerator isn't going to go out. And even having a generator isn't going to make you feel comfortable enough. There's certainly a lot of things like that. The gases, all those sorts of things, being able to set yourself up to have different gases in the future.
Jay, why do you think it's important to bring on a construction manager early in the process?
So we all have our part in the play. We have the architects and the engineers who design it. And then we have, obviously, the builder who's going to build it. And we operate on a collaborative basis. So each time a set of documents are issued, we take the time to review them. And not only do we review them for, budget and schedule, we also review them to make sure that what we have on paper is constructible and can be done in the field. A lot of times when we work out of the office, we come up with some great designs that functionally, when we get to the field, it just can't be put together that way. So it's always good to have the contractors review the documents to make sure, A, we can do it the way we're talking about, and that the idea that's coming from the team in the office can actually be executed in the field. We're a valued team member because our value is that we've done this before, we know how to do it, and we know the one thing all of us will remember is we all know what doesn't work way more than we know what works, right? Some of the designs we see are new. Again, I talked earlier about artificial intelligence and robotics. A lot of us are on the cutting edge of that type of stuff. So understanding how that stuff works and how we can incorporate it into the building, you really need the builder's perspective to do that. And, also there are times when we look at the buildings and we look at the client's budget and they're not on the same tier. So a lot of times we get into value engineering to help the client meet their budget goals and also their schedule goals. We also get into reviewing each item and how it affects our schedule, and that may get us to the situation where we, on some of these larger out-of-the-ground projects and even some of the rehab projects, we're into early release packages that help the client get to that all-important speed to market. And that's really what we bring to the table.
And just to reiterate on that, from my perspective involved in the programming of projects, again, I start developing a construction schedule right from the get-go. I try and help identify what those long lead items are going to be so that early procurement packages can be obtained. But one of the other things is the whole permitting process. A lot of times, by getting us on board early during the planning stage, we can meet with the different code officials, building department, fire department, Board of Health, Conservation Commission, tell them what the project is about, find out what their concerns are to help pave the way for the permit process to go much smoother.
Well, it's been great having you all on this month's podcast. Thank you for sitting down with me. Special thanks to Greg for moderating today's episode. Can you tell the listeners the best way to connect with you if they have any additional questions regarding CoLab Solutions?
Yeah, so if anybody has any questions, I can be reached at gconboy@erland.com.
Awesome. That's it for today's Tried and Blue. We hope you join us next time for another exciting sit-down with other Erland team members and maybe even a special guest. Keep checking our website to tune in.